15. Where are we now? I think it started a new video. Was that second? Yeah. Did I really go that long? It's already more than 20 minutes. Oh. I should have made a separate video of the chapter. Made 3 different videos. One, okay, elements, atoms, size. Chemical compounds, chemist, heat, caloric, measurements, chemical interactions, ratio of masses, combine. Okay, here it gets a little bit condensed. Atomic theory. So at this stage, the atomic theory emerges. Atoms were given element identical in size, mass, and other properties. Okay, size and mass. Cannot be subdivided, combined, chemical reactions. Basic ideas of what is meant by atoms. Basic ideas of atoms. Size, mass, and they combine. Sixteen, 17. So the theory of atoms, interaction of atoms, interactions, this word keeps coming up, interactions of atoms, combine, molecules, chemistry, tabulations, new elements, Mendeleev, chemical properties. So at this stage, chemistry, chemical reactions of various elements are investigated. And new elements discovered. Periodic table of elements, column, gases, believe that nothing more than a theoretical construct. People didn't believe in this atom story, it seemed. Then the electron, the subparticle. Yeah, I'll just talk about the periodic table. further into this. And then the story of electrons emerge. The structure of these atoms. Structure. So now the story emerges that the atoms are not, these basic particles of matter are not, can be subdivided. They are smaller parts to them. Subatomic particles, static electricity, electrical fluid, electricity, emit negatively charged particles, cathode rays, internal structure of atoms, internal structure of atoms, electrons emitted in a circuits, electricity, fluids, electric fluid, spectroscopy, so now they found emissions, electron emissions from matter, and making light with matter. So light is coming into play. That's page 20. Plum pudding model, literally positive and negative car pictures. So what? So the model of the atom. How is it constructed? Because we've got these positive and negative particles. Electricity is about charged particles. Active elements emitted. So there's radioactivity. That is the emission of charged particles, very high speeds, and Rutherford investigated using this radioactive part emissions or rays, proton, positive nuclear charge. To investigate the atom, radioactivity, proton, nucleus. So they're looking inside of the atom now. How is it constructed? 20 atoms emitting other forms of matter called radioactivity signal the fall of the last recognizable element of the ancient philosophers. The composition of matter. Atoms were indeed real features of the physical world, but they were not eternal. So So meaning they can change. The search was now to understand they were subatomic particles. So subatomic particles. And then comes spectroscopy. Analyzing light. Atoms producing light. Prismatic technique. Separate the light components. 22 rainbow colors. Spectral lines. Fraunhofer. Optical performance, white light, monochromatic, filtered, pinhole, slit, dark lines. That's absorption spectra. Eliminating the prism using a diffraction grating to disperse the light in wavelength. Waves. Lines, spectral. Again, a story about spectral lines, atoms, discrete emissions. And then I talk about Fraunhofer. Sodium D-line, sodium spectrum, dark lines, absorption lines, solar spectrum. So they keep on referring him to absorption lines. You get the continuous emission of the sun, and then some elements in the atmosphere absorb that light. So there you get a dark light. So there's a continuous emission, and then you get the absorption lines, dark lines in the solar spectrum. Calcium, Betelgeuse. So they're in the stars, planets. Something about the stars. Sequences. Gas. Numerical law. So we've got some formula explaining the lines of hydrogen. Different stars with different spectrum lines. I think this might be absorption lines. It's some constant. Okay, what am I going to write here? Stars. Absorption spectrum, different elements. There's some formula for the wave, light, And here it's beginning to come out the quantization, quantity, quantum property of atoms and light. That's spectrum quantizer. Atoms, there's some quantum processing going on. It's not a continuous model structure. As each atom line, velocity, acceleration, continuous variable mass, discontinuous jumps. Energy, atomic spectral lines, there were not an unlimited number of ways that M can emit like. So here's the energy levels and the quantum numbers and the various spectrum lines. This is the atomic quantum levels. Quantum numbers, and energy levels. What do we have here? Dalton's emission, interior of the vibrating rings, loops of knotted ether. So we're trying to explain how does this come about. It's like you've got these quantum processes, charged particles, radio waves. Gave any clue to discrete emission mechanism. Trying to explain the discrete emission spectrum. How does that come about with the atom? How is the atom constructed so that it can produce these discrete structures? There's something quantified about it. And that's the summary. Where am I now? 18. Early models of the matter favored basic continuous media. So Earth, fire, continuous. So these air, earth, fire and water show that theory favors continuous medium, while atoms are little particles with definite properties, and the spectroscopy, periodic and narrow spectral lines, atomic identifiers, chemists, elements, models of the atom, plum pudding model, positive and negative charges, Rutherford model, narrow single frequency spectral lines could not be understood in terms of the known theories of the production of light. That's the takeaway. Spectral lines, spectrons, discontinuous, continuous, or discrete spectra. How does that come about? Atom structure. Okay, that is chapter 1. So that is chapter 1 in brief. And then let's save this in an envelope. Quantum physics, then Edinburgh, chapter 1. So I can have a look at it again, just to refresh my memory. Ooh. Let's hope it's narrower along the one edge, so that should get a bit lower. Okay, that was a quick review of chapter 1.